Good afternoon, stakeholders. Today we are presenting our machine learning system for medical diagnosis. The problem we are trying to solve is identifying patients with and without melanoma accurately in order to provide medical treatment. Through the advancement of artificial intelligence, we are able to solve the problem at hand. As a high risk factor to health, melanoma is one of the most prominent brain tumors that cause death. Through tackling our problem, the majority of these deaths can be prevented if diagnosed early with our proposed AI solution.
Our project is to create an artificial intelligence system that is able to accurately diagnose patients with meningioma efficiently based on MRI scans. Our project must be able to differentiate between healthy brains but also brains with other types of tumours, such as pituitary or gliomas. These extra categories further help with the accuracy of an AI artificial intelligence system. Expanding upon our previous medtech research, we first used Teachable Machine to import test data that was separated into healthy brains and brains with the aforementioned tumours. The problem we are trying to solve is identifying patients with and without meningioma accurately in order to provide medical treatment. In our project, artificial intelligence is utilized to diagnose patients with meningioma with precision, accuracy, and validity. Based on our previous research regarding medtech, we were able to take into account of all of AI's unique ability to tackle the problem at hand. Using AI's unique perspective abilities allowed us to identify the differences between patients who correctly diagnosed them. Representation and reasoning as part of AI allowed teachable machines to correctly represent the group process data. By importing a large dataset, our AI was able to learn the differences between the control groups and the MRIs of patients with diseases. As the dataset imported increased, it allowed AI to learn more and make more accurate predictions or judgments of the absence or presence of meningioma and other diseases. Human-AI interaction allowed our AI to improve through our adjustments. Human-AI interaction also allowed us to resolve our problem, being able to successfully complete our task of AI support in order to identify patients with and without meningioma accurately in order to provide medical treatment. Last but not least, AI has the ability to tackle the problem at hand and to positively impact society through the means of improved health of the targeted demographic of patients. Here's a link to our final Teachable Machine product, which we have created.
Here's a demonstration on how our Teachable Machine can be used. First, you need to import a file from either the drive or your personal files. And then our Teachable Machine will be able to scan and diagnose the image as having melanoma or not. In this case, the brain scan does have melanoma. You can take a look at another example here where we import a file which does not have melanoma. And here, as our Teachable Machine scans it, it also correctly diagnosed that it does not have melanoma as well.
Here is our comparative table. As you can see in Article 1, which is the use of advanced neuroimaging and artificial intelligence in meningiomas by the Organization of Brain Pathology, that was published in 2022. It covers the medical condition of meningiomas and works by using something called radionics, where AI is used for computation, identification, and extraction of image features so that tumors are easily seen and diagnosed by diagnostics. It uses around 500 epochs and uses around 10,000 images for training data. The overall accuracy of this system is around 87%. For Article 2, which is the use of radiomics and machine learning that accurately predict the grade and histological subtype in meningiomas using conventional and diffusion tensor imaging by the Organization of Web of Science, published in 2019, also covers the medical condition of meningiomas. In this article, AI is used to calculate mathematical data from brain scans and presents it in the form of something called radionics, which diagnostics used to diagnose patients with meningioma. This one only uses around 550 epochs and uses around 6,000 training images, but this accuracy is around 90%. In Article 3, it is the imaging system and AI algorithm that accurately identifies brain tumors. It is by healthcareineurope.com and was first published in 2020. This covers the broader term of brain tumors, and it works by a deep convolutional neural network with an extensive list of training data separated into different categories of brain tumors. The AI system becomes able to diagnose these meningiomas. This uses around 50,000 epochs and has around 2.5 million sample images. The accuracy of this system is around 95%. In our last article, in Article 4, it is the fully automated detection and segmentation of meningiomas using deep learning on routine multiparametric MRI by the National Library of Medicine. This was published in 2018 and covers the medical condition of meningiomas. It works through deep learning. The segmentation of MRI scans of brains can be analyzed by artificial intelligence to help clinicians assess patients that could possibly have meningioma. This system has around 100 epochs and uses around 5,000 training images. The accuracy of this system is around 86%.
In response to recognizing the importance of ethical considerations during the creation and production of our artificial intelligence system, we have decided to implementations according to the 8 artificial intelligence principles. Here is how we have taken the principles into serious consideration.
Here we can take a brief look at how we have considered the 8 artificial intelligence principles recommended.
That brings us to the end of our presentation. Here are a list of references used for the research, planning, and creation of our machine learning system used for medical diagnosis with the use of AI. Thank you for listening to our presentation.